All right, I get 2 past the hour. So, hello and welcome to today's webinar, Optical LAN Connectivity to Anything and Everywhere. My name is Scott McIsaac. I'm a member of APOLAN's Technology Committee, and I'll be your moderator today. Before we begin the presentation, I'd like to cover the agenda and a couple of housekeeping items. First, your audio has been muted today for everyone except our presenters. For submitting your questions, please use the question and answer key feature on your screen throughout the presentation. We'll do our very best to answer as many questions as possible, and the earlier you submit, the better we'll be able to manage our time. Secondly, the presentation slide deck will be emailed to all registrants after completion of the webinar and includes information about APOLAN's benefits, resources, and contact information. On the next two slides, we invite you to take a moment to review APOLAN's antitrust, no solicitation policy, and legal disclaimer. This should be on your screen now. We'll pause for a moment so that you can review that. Excellent. So today we have the four of us on the webinar for your enjoyment. Again, my name is Scott McIsaac. I'm the moderator. I'm a technical account manager with Tellabs and a member of the Technology Committee for APOLAN. Also with us today are Brian Hardy. Brian, would you like to introduce yourself?
Sure. I'm Brian Hardy. I'm the Executive Vice President for IT Connect. We're an integrator. I'm also on the board of directors for APOLAN, and I'm a board liaison for the Technology Committee.
Excellent. Thanks for joining us, Brian. Blaine, how about you?
Good morning. My name's Blaine Overstreet. I'm a senior solutions consultant with AECOM. I am a member of the APOLAN Technology Committee and a former chair of the APOLAN board.
Awesome. Glad to have you here. And last but not least, Chad.
Yes, good morning, everyone. My name is Chad Hines. I'm a sales engineer with IT Connect. I am the vice chair of the Technology Committee with APOLAN.
Excellent. Thank you all for joining us today. We can advance to the next slide. All right, we've already covered the housekeeping items. Next, I believe Brian is going to, or is it Blaine, covering the optical LAN overview? And then we'll merge on into where optical LAN fits best, or the anywhere portion of our agenda. And then finally, the things that can connect to optical LAN, the anything values.
Thank you, Scott. We'll jump right into it. Most of you all have probably heard already about passive optical LAN or have been exposed to the technology in some way. So we'll just kind of give a high-level overview of the different components. POL consists of 3 different components. At the head end, you have something called the OLT, optical line terminal. That is connected on each side. On the upstream side, it's connected to whatever your core switch is. So those could be like a 1 gig or 10 gig connection to your core switch. That's where all your layer 2 MAC addresses are going to be sent out to the core for distribution throughout your network. On the other side of the OLT is going to be one strand of single mode fiber. That's going to connect to an optical splitter. That splitter is going to take the one fiber, split it into multiple fibers, and then those are going to plug into what are called ONTs, which are optical network terminals. All of that in the middle is passive, and at the ONT, that's where you would plug in your device, whatever the device is, which we're going to go through a lot of them today. As it relates to different flavors, our next slide talks about the different types of OLTs. You have large OLTs, you have small OLTs. The ones that we're looking at here are are kind of some different flavors. You have options for fully redundant OLTs. You have AC and DC powered OLTs. If you look at the top one, the bottom two cards, those would be the Ethernet switching units, which connect out and send your MAC addresses. The two bottom ones, those are the middle cards. That's where your uplink to the rest of the network is. And then the cards distributed out to the right would be your optical cards. The next slide has some smaller versions of OLTs, which can get as small as 1U units. Despite the size, they're massively powerful. You can, connect hundreds of ONTs up, each ONT having multiple Ethernet ports that you can plug into. So again, these small ones, they are probably a little bit more for a smaller office, but you can still have hundreds of ONT port or ONTs connected to them with hundreds, if not thousands, of Ethernet ports, even in a small compact chassis. As it relates to that middle portion, the next slide talks about the different types of splitters that you can have. So as previously mentioned, you have one single strand of single bone fiber that connects into what's called an optical splitter. That splitter can take the one fiber and split it in up to 32 different fibers. But depending on your use case, you may only need to split it twice or 4 times or 8 times or 16 times, depending on your specific use case. These are some pictures of what the optical splitters look like. You can buy them rack mounted, you can buy them cassette, you can buy them freestanding, I guess, if you would like. But again, a lot of different flavors for a lot of different implementations. The last component is the ONTs, and there are a variety of them, as we'll talk about a little bit later today. In the use case scenario, you have tons of different options for anything that you want to have connected. The ones that we're looking at here, you have a couple 4 ports, you can have a couple 8 ports, some other notes on them that you can have coax TV connected to the back of an ONT. And for those who are in hospitality or other industries that still use analog phones, you can actually have analog lines coming out the back of the ONT. So you can actually extend your analog voice network over your optical network. Some additional use cases, we have as small as a 1U, which I believe will be presented on the next slide. Yeah, we have a 1U ONT, so that's just kind of for one device to plug in. And you have all the way up to 48 port, which kind of mimics and looks similar to a traditional 48 port switch. You have in-wall units, you have cubicle units, you can plug them above the ceiling. There are just a tremendous amount. Indoor, outdoor ones are also some. So if you needed to put some in some light poles outside, they have some that are weather tested and related there. So there's a variety of different ONTs as well as OLTs as well as splitters that you can use in your deployments for anywhere, anything. And with that, I think we'll turn it over and start discussing some of the different use cases.
Thanks, Brian. So we see hospitality as one of those market verticals that's really excellent fit for optical LAN. You have enough density to show a CapEx savings and an OpEx savings. It could be 300 rooms. Some hotels are smaller, but you can really see some synergies in when you're not only when you're building that hotel and reducing the CapEx needed to build it, but also in the operation of it. One of the things that really can increase the cost of CapEx for hospitals are all those technologies that they're integrating. So whether it's the LAN services at the front of house and back of house, or the public internet that's used by the hotel attendees, you're obviously that's going to be wireless and wired. Video services, you could have a video head-in that exists at a hotel today. If they migrate to an optical LAN, we can actually accommodate both an analog input on that infrastructure as well as on the back, as well as a IP video distribution. Security systems, HVAC, and even distributed antenna systems. So distributed antenna systems are those systems that get deployed inside a building to boost the cellular signals for convenience. Although they can't really be switched like Ethernet through the optical LAN infrastructure, you can deploy that fiber optic infrastructure on day one with an overbuild that will accommodate that distributed antenna system. So that's definitely an advantage there, in that you're building one infrastructure out to support all the technologies. The present mode of operation for, if you could go back one, the present mode of technologies for a hotel operator or the present mode of operation for those technologies in a hotel is to utilize whatever infrastructure they put in years ago. Oftentimes it can be quite aging, but that might be DSL, cable, Ethernet, analog voice. There's no reason why going forward we can't have a big shift in the paradigm where you're actually converging all these technologies over that single mode fiber. And what that's going to allow you to do, you can go to the next slide now. What that's going to allow you to do is maximize your revenue over time, so that operationally you're not taking rooms out of service to revamp the copper infrastructure to a fiber or what have you. Once you have that single mode fiber deployed, you can connect all the devices on it, and it's really efficient and easy to operate. The hotel operator can get training on the management system of it, which is usually a graphical interface, and allows you to slice up your network for different purposes. For example, you might have the back of the house network, you might have some third-party vendors operating a restaurant or bar. Those kind of networks are easy to slice up. It's just a VLAN that you configure on your network and apply at the ONTs where you need them. And then again, as the technology changes, you only need to replace the endpoint. And the one item I definitely should point out for hotel operators or developers of hotels is the small footprint that you get with an optical LAN. We can deploy passive fiber optic throughout the floors of a hotel, and really only the active devices exist at the endpoints, at the head end of your network and at the guest room. So everything in between is passive, and you don't need a telecommunications room to house that, although you might include a telecommunications room to support powering of it if you choose to do remote powering of your ONTs. So there's a lot of options for you in this particular market. Next slide. So another vertical that's a really nice fit for optical LAN is manufacturing. This might also just have the same advantages in a warehouse distribution environment, but manufacturing is really a critical business. It requires redundancy, it requires resiliency, and some of the present mode of some of the aspects of the present mode of operation for manufacturing is that they often will put network racks, small clusters of racks, way up high in the high bay areas of a manufacturing environment, so that it doesn't get just damaged by forklifts or any operations going on. While that has served us well in the past, it's very expensive to do moves, adds, and changes. You got to get somebody on a man lift and get them up to that equipment. Also, as equipment needs to be replaced or cabling needs to be replaced, it can be very costly. By deploying a passive optical LAN in those manufacturing environments, you can get a lot of synergies and cost savings, which I'll go into in a minute. But again, the current mode of operation, each rack that you deploy in that manufacturing environment might serve a relatively small number of connections. That is, you might have 3 or 4 manufacturing equipment, you might have a couple of workstations for the employees working there, but not a whole lot of density. The problem is that density gets spread over a very large area in that manufacturing floor, and therefore it gets expensive to deploy those rack mount switches. Also, there's some temperature and ruggedization required, or temperature high temp thresholds for some of that equipment. So you need devices that actually can withstand the rigors of a manufacturing environment. Could be vibration, could be high temp, but you not only need it to be ruggedized, you also need it to be small footprint, and optical LAN is a great fit for that, and I'll go into that on the next slide. So by deploying optical LAN in these environments, you're going to improve safety and efficiency by not needing to get up into those high bay areas. Day one, you deploy all the fiber you need down those columns, and you're going to actually terminate it in a traditional faceplate, or even inside a manufacturing piece of equipment. You might have a cabinet for telemetry and network connectivity inside that equipment. You can deploy ONTs inside of it. They're going to free up space by doing that. The ONTs, they're going to be as close as possible to the endpoint as they need to be served. So it might be a workstation, it could be a piece of equipment, as long as it's ruggedized and meets the need, and there's lots of options for that. That overbuild of fiber that you deploy on day one, it's relatively cheap to deploy additional strands of fiber, is going to serve you down the road by not having to go and get the man lifts out and install new cable way up high. You're going to have plenty of capacity for future growth down the road. And then finally, because the service provider has demanded redundancy and reliable network when this equipment was developed for the broadband industry, we can now take that same architecture, which is duplicated switch cards, duplicated power supplies, even duplicated PON ports if you need that. So you can actually get a high availability solution in these manufacturing environments. Next slide.
Thank you, Blaine. Another one of the largest growing verticals we see is the educational environment. We're seeing large amounts of equipment, BYOB installations, bring your own devices, high bandwidth wireless installations. Now we're seeing a lot of video surveillance and access control systems. They're really locking down these facilities. We're seeing digital equipment in the classrooms, touch panel displays, digital signage. They're using digital signage for emergency notifications, menu boards, control systems, monitoring the health of the facilities, usage of the facilities, be it solar. One of the largest concerns with education is space and costs and savings. So with optical LAN deployments, we're reducing the amount of telecommunications rooms in a single facility that maybe was 3 or 4 on different levels of a facility. We're really reducing these down to either a single IT closet where everything is distributed from there, or multiple IT closets, but we're reducing that equipment footprint more onto a passive level. So with that passive level, we're reducing our cooling. We're no longer needing these HVAC systems. That extra power were needed for battery backup systems and all of that legacy switchgear, we're no longer operating. So with the educational environment, it's vastly growing. One of the largest things with education are large campuses. The larger our campus, the more cost savings we see, because we're reducing more IT closets, cooling, and power. We're reducing our footprint, saving that square footage, utilizing it for actual storage rooms, right? Typically, when we open an IT closet in a school environment or an educational environment, we see a lot more than technology equipment, right? We're seeing boxes, we're seeing files, we're seeing brooms. So now we're really consolidating this equipment and giving space back to the facilities, or utilizing that space for other things. When Brian mentioned previously about the optical splitters, the footprint of this equipment is very small. These splitters can be installed in NEMA enclosures on the wall. They could be installed in ceiling enclosures, and that's really where we're reducing and eliminating that footprint by moving things elsewhere. We're no longer needing these equipment racks. One thing I like about large campus environments, you'll see we have 2 different pictures on the slide. The one on the left was actually an installation from an integrator within the association. That's actually, he referenced it as a jungle. And what it was is lots of buildings over a large footprint of really a jungle type of agriculture of space. And there were no pathways between these facilities. It was very difficult for them to get pathways. So in order to accomplish that, installing smaller pathways was to go with fiber and deploy passive optical LAN in these smaller facilities rather than installing switch gear. Each facility would just require a single ONT to power those users. You know, from a single 8-port, we would cover a security camera maybe on that building and probably most of the equipment within that small little facility. What I like on the picture on the right, we're seeing a lot of higher ed customers really growing. As I mentioned, the larger your campus, that's really where you start to see cost savings because we're eliminating more of that equipment. We're no longer needing that layer 2 switch gear, because that's what we're replacing with optical LAN is all that layer 2 equipment. So we're no longer needing that equipment in these buildings. We have a single OLT chassis in, you know, their central office, their central server room, and we're just deploying a passive infrastructure throughout that entire campus, up the risers to rooms with optical splitters. And that's really what's feeding these ONTs in every one of those buildings. Essentially, we're eliminating 100% of active equipment in some of those buildings. I like to reference a K through 12 environment also in large campuses, because if I had a small town and I had multiple schools within a specific, you know, relatively close to each other, maybe split by a street, an alleyway, with optical LAN, we could install an OLT in one site. We could get fiber to another site and connect that entire site to the OLT in another facility. What's great about that is if I was paying for Ethernet services, an optical circuit, whatever type of service at that second facility, and that type of installation, we would be eliminating that service at that facility that would go back into the school, right? If I wasn't paying, you know, $3,000 for Ethernet services at one site because I was able to tie it into another school, I would essentially be saving that cost, which may in turn pay for the network itself. A lot of people don't know what pays for the utilities and services of a school is what's coming out of the capital budget in an educational environment. And what also comes out of that capital budget are salaries, teacher salaries. So, you know, any way you can help your customer and get that across is a really good point. It's also E-rate fundable. So in terms of education, it being E-rate fundable is a really big topic for the educational environment. And if you were able to eliminate 100% of switchgear and active components from one site, it may even qualify for priority 1. At that point, you'd be moving server equipment. You would need nothing at that second site, which, you know, may qualify. So always great things to think of. When we look at sports entertainment, what do we think of? We think of large, massive facilities. If you've ever actually walked in a complete circle around a sports venue, it could be miles, right? If you would consider the amount of TRs you would need to operate a facility like that, all of the vendors, security, and most importantly, we like to reference wireless. The amount of people in a stadium is huge. Tens of thousands, sometimes hundreds of thousands of people in a single location. So what do we need? We need a massive wireless infrastructure. One of the ONTs Brian highlighted in the beginning was a single port ONT. It's an industrial ONT. It's hardened, and that ONT specifically was created for a sports entertainment facility. Their ONTs were installed underneath stadium seats to deploy wireless. I mean, mass amounts of wireless devices around these facilities. Those boxes were getting hot. So that manufacturer actually, right on the fly, created that ONT to be installed in that sports entertainment facility to, power up just a single device for a wireless access point. It delivered PoE services to power these wireless devices. So when we think of sports entertainment, lots of equipment rooms. Moving to optical LAN, we're now able to remove those equipment rooms or those cabinets you typically see on the wall in those manufacturing facilities. That's where you would see a lot of these entertainment venues. But due to optical LAN and our distance going up to 20 kilometers, we're really able to eliminate that. And I don't know if we highlighted that, but with copper installations, we're limited to our distance to 100 meters, and that's a copper limitation, not an equipment, but it's copper limitation. So when we look at optical LAN, we're talking 20 kilometers, roughly 12 miles from the OLT to the ONT, and that's really how we're building these large campus environments and these stadium environments, eliminating these equipment rooms. So we like to highlight these large customers.
Hey, thanks, Chad. I completely did not cover the 20-kilometer discussion there from the OLT to the ONT. And that is really what allows us to be able to kind of give that stretch. So as Blaine was talking about in the manufacturing world, you only have to have that one equipment room in a warehouse, and your fiber can go 20 miles around that warehouse without having to have another distribution point,
20
which
kilometers.
which will, yeah, 20, I'm sorry, 20 kilometers. So it really helps with the stretch within a campus. As Chad was talking about, you have multiple buildings. You just have to have that one ER room. You can stretch it across the whole campus, and not have to have a room in every building that's just kind of dedicated to, massive amounts of equipment. Healthcare, no different here. The challenge in healthcare is you have a bunch of different services that need to run across the infrastructure, and they can't really touch each other. You need to be able to protect patient privacy, as well as kind of do some ad hoc on the fly reconfigurations of rooms, and that's where optical LAN kind of comes into play here. So if you look at a hospital, kind of from the outset, you have obviously the patient care, but then when the patients are in the room, what are they doing? They're watching TV, they're talking on the phone, they need access to Wi-Fi. Some of them actually want to do some work while they're in the hospital, if they can, catch up on some emails, and you need this kind of critical infrastructure just for that patient side. On the back end side, you have nurse paging systems, you have physicians that need access in information, such as maybe they need to look at your x-rays, and this is going to be kind of all ad hoc on the fly. They bring in their portable device or their laptop, and they're pulling up your records in your particular room. At the same time, you have general building things that need to operate in that facility, such as your HVAC, your security and surveillance, your access control. All of these things kind of all run on an infrastructure. And the great thing with optical LAN is you can have that in one kind of set of equipment. So you can break it out via VLAN. So everybody has kind of their own little separate network, which is secure. You're not allowing, any cross contamination of physician data with patient data. And then you can also egress. So as those VLANs come through PON, you can send one service out one interface, another service out of another interface to different other service provider equipment that may be in the head end. As it relates to reconfiguration of the rooms, is another great thing about PON. So you can run different strands of fiber to a critical care room. So let's say you have 4 strands of fiber in that room. So you can kind of on the fly, you can reconfigure the room. So you can have one fiber dedicated to maybe a quad ONT that's going to deliver these kind of services. You have another one going to maybe a 48 port. I don't know, maybe they need to reconfigure a patient room to do temporary imaging of desktops or something like that. So you can throw in a 48 port ONT and reconfigure some or reconfigure it so they can do some imaging. But there's a ton of flexibility that can be done in there, and you can kind of swap services on the fly. Oh, you know what? Let me talk about one more thing. So in a critical care healthcare environment, you also need some redundancy. So we didn't talk really about a lot of redundancy, but what happens if that head-end OLT piece of equipment that we've kind of put everything on, what happens if that were to fail or one of those PON cards were to fail? So within PON, you have redundancy called type B. We won't get into the specific details, but let's say you can actually have two OLTs in maybe different head-end rooms. And what they're doing is they're constantly synchronizing with each other. So if one card in one system fails, it automatically fails over to the next one. That's a big deal in healthcare because you need to make sure that you have that uptime. You take your redundancy along with your DC power plant and battery backup. Now you've bumped up your uptime far beyond where it could be with traditional active Ethernet.
Thanks, Brian. So let's jump to a completely different vertical, and that's government. We'll talk about the different types of government implementations you might see. But some of the high-level advantages in this environment is many times the buildings that we're seeing in government deployments are historical buildings. So there's a lot of focus on ensuring that the historical integrity of the buildings there. There's usually not a lot of space for technology. So telecommunications rooms can be hard to place and dedicate. There's also some power, space, and cooling constraints. One of the things that an optical LAN does is it eliminates that telecommunications room, which may have multiple switches deployed in a rack. Those switches obviously require power and they dissipate heat. So you often see in those TRs, you might see a 1.5 to 3 ton air conditioning equivalent requirement. That gets completely eliminated, and the heat load that's in those tiny little ONTs is very small. It gets dispersed in the large comfort cooling zones of these buildings, so it's a lot more efficient from a power, space, and cooling capability. Also core holes, that's the holes that are drilled between floors to get cabling through the floors to the next throughout the building. We can use very small footprint of a core hole to put a very small footprint of fiber that can serve a very large number of network devices. So that's another efficiency we see. And then obviously these are often large buildings. You get into municipalities, federal buildings, they may be 100-plus-year-old buildings that sprawl with multiple wings. Great application for optical LAN because we really don't care about distances. We can propagate those signals over that single mode fiber for many thousands of meters. Federal government, that's really where passive optical LAN started. It came about because of power, space, cooling requirements, and most importantly, security requirements. So some of our government customers with very high security requirements, they requires multiple networks to the desk. So you might have an unclassified workstation, and you might have workstations that are at higher at classified information. So it has to be air gap separated. They prefer fiber to connect these devices. And so optical LAN is a perfect fit for that while also reducing that power, space, and cooling. So that's really where this technology took off in that space. And certainly those advantages spill over to multiple verticals of enterprise. Some of the manufacturers have also integrated a lot of technology features that you would see in traditional switching environments that you can then deploy in those end user environments, those secure environments. Next slide. Local and state government, we've seen a lot of activity in recent years where local governments, they often own their own fiber in the ground, and many times they don't really fully utilize it. They're sort of doing if you build it, they will come approach where third parties might take advantage of it. But one of the things you can do with an optical LAN technology is consolidate. I think Chad touched on this earlier. You can consolidate your services, your telephony, your internet spend, on those multiple buildings. So think of a municipality with a high school and fire stations, police stations, administrative buildings. If you have fiber between those buildings, you can converge all of the higher end technology, the core network technology, like your telephony systems, your access to the internet. You can consolidate them at one location and distribute them via that fiber infrastructure, and therefore eliminate the technology spend at those remote locations in that local or state government. We're also seeing these local and state governments adopt broadband plans where they're actually using it for low-income housing, or even just as another competitor in the local market for broadband access. Next slide. Transportation. We've already seen some deployments for rail and airports, and some ship deployments. Railways take advantage of it already. They already have single mode fiber, and they can readily use the technology of optical LAN to connect those sensors, the telemetry, the surveillance cameras that are needed along those tracks, as well as all of those technologies that are in those often very large stations that allow either cargo or passenger traffic. So by deploying that fiber along that track, you can cover those long distances as needed. And we're seeing now today where deployments on rail are now starting to integrate 5G technology. So we're putting 5G technology over that optical LAN and allowing that to make a better experience for passenger rail. Airports, we've seen deployments in China. There's multiple places in the United States where airports are making use of this technology. What we see with airports is they're often a multi-year projects that appear in different places. For example, a parking garage or a specific terminal at the airport needs to be refurbished. Optical LAN allows you to do that by again reducing that telecommunication room footprint and taking advantage of those distances. Cruise liners is something that many integrators are trying to get our foot in the door. It's sort of like a country club environment where only certain integrators and technology consultants are at the table for these cruise ships. But it would be a great application where you could actually take that modular footprint that they deploy these ships with today. The cabins and the various buildings are prefabbed as a modular building with connectorized fittings for electrical and other technology. So the same thing could be done with an optical LAN where you just modularize it, put that ONT where a wireless access point is, where an access control system is, and there's a lot of synergies there. Naval ships, same approach. In this way, we would make one of those high redundancy systems that Brian talked about. So you have an active and a standby OLT. Maybe one's on the port side of the ship, one's on the starboard side of the ship. So if there was any attack, it could fail over. But again, the beauty is that the fiber footprint on these ships is going to greatly improve the overall weight. You have thousands and thousands of pounds of copper cabling that get deployed for telecommunications. By replacing that with nearly all fiber, you're really reducing the amount of net tonnage that you have in that ship. Next slide.
Yeah, thank you, Blaine. One area people don't really like to or consider is meeting rooms. Not necessarily a vertical, but what we have in all of these different verticals are meeting spaces. And we like to highlight this because this is a space, right, where we're talking anywhere. So this is a space that's vastly grown within the last few years, with all of the issues in the world today. Everybody's going virtual. Which is creating larger meeting spaces, which require more wireless, lots of video transmission, guaranteed video transmissions, voice. We're talking video decoders. So I won't spend a lot of time on this slide, but we like to highlight the anywhere in this topic. We're going to touch on it more once we get into anything, but we really are talking anywhere. So we're gonna jump right into our anything and what can we connect? Anything.
Yeah, and I probably hit a couple of these points when I was talking about healthcare. I got way ahead of myself. I'm very excited about technology, as you can tell. But basically the takeaway from this is kind of look at healthcare in four different areas. You have the patient area. Those are where I was talking about the person that's maybe has a knee surgery, but they're wanting to use their laptop to be able to check email if they need to, or use a phone. And they need that kind of consistent, reliable coverage, along with maybe they need to do video conferencing or something like that. But additionally, you have maybe the patient in the next bed doesn't want to do any of that. They just want to be able to watch movies on demand or something along those lines. So that's kind of that patient-centric system. The next one is the physician side, where they may be doing mobile visits. They may not even be on a floor. They may just be in their office and kind of doing some virtual patient visits, or they may be walking along the floor with their tablet, looking at X-rays, getting briefed before they go in to visit the next patient. The third area would be the kind of the infrastructure, or the intelligent facilities, I think is what is called on this slide. But that's where you have like beaconing and location, so they can track patients throughout the hospital, or people throughout the hospital, or even if you want to do a study to look at traffic flow to make sure that they're kind of coordinating off the corridors correctly. And then the last one is actually the back-end building automation system, so the HVAC systems that connect to it, and the access controls and security. One of the biggest things in healthcare and across all verticals is wireless. And the next slide kind of talks about that. You have your kind of iterations through the wireless infrastructure, where you went from Wi-Fi 4 to Wi-Fi 7. And the common theme there is it's just more bandwidth that's needed. There's a demand from the end user to get more bandwidth. That means the access point needs to now connect at a higher and higher and higher and higher speed. And that adaptability is also there with optical LAN. So what I mean by that is once you start getting into the higher Wi-Fi numbers, what you find is the back-end connectivity is a more demand. So it went from 100 megs to a gig to multi-gig connection on the back end. On the front end of that, where you connect up, now your speeds connect faster. So instead of connecting at 10 megs or 20 megs, you're now connecting at a gig. And there's maybe 30 people in the room that connect up to that access point, and then they have to have that back end flow high enough. So with optical LAN, you have different technologies that you can just, again, you can maybe unplug an ONT that was the traditional GPON and then plug in the newer technology PON, which provides those faster speeds. So it's very flexible and very, very adaptable. And I think that's probably enough to talk about wireless here for a minute.
One thing when we look at building automation systems, which are vastly growing in every one of these verticals, everybody's trying to create a synergy between all of this equipment. They're trying to centrally locate it. They're trying to centrally manage it. And that's across all verticals. They're really trying to build these green systems. And with optical LAN, we're able to do all of this with a single infrastructure versus different types of infrastructure, different types of equipment versus one network, one set of hardware running our HVAC controls, another set of hardware running our lighting systems, our security. A lot of times customers will, I need my security network completely separate, hardware network interfaces, right? With optical LAN, we're really able to segregate these networks more efficiently. We're able to provide better redundancy at times. We're installing a single infrastructure. As Brian mentioned, we're able to adapt to newer technology as it comes out just by swapping out an ONT versus a large Ethernet switch. So with building automation systems, we're managing all of these things from HVAC controls, manufacturer lines, energy monitoring from solar, energy systems, curtain controllers. Really, we're talking anything. So data center management, lighting systems. That's something that's actually growing pretty heavily because people want to be able to control these lighting systems to better the environment that we're in. That really gets into the wellness of a facility when we look at it as an AIA perspective in designing these systems. How are we bettering these facilities versus creating these facilities? We want to manage these lighting systems, which have lots of network interfaces throughout the ceilings and the facilities. Then we get on to security and door control systems, security surveillance, gate controllers, where we're going long distances out, and then solar array and digital signage. So we're really combining all of these systems into centrally managed devices. We touched on this a bit already, but analog voice systems, a lot of people go, analog, what are we using analog for anymore, right? We're IP. And a lot of people don't consider these when they're building facilities. Oh no, I still use that fax line. And they'll design these facilities and go, shoot, I still need to order that analog circuit. They are used, right? So that question comes across when we're doing optical LAN. How do we do that? Well, it's great because we convert it to IP. We break it out at the end we convert it to SIP. We break it out at the ONT, and we deliver those analog services just as you would previously. Your handsets. Another one are these emergency phones and elevators or stairwells. Some of those higher ed customers, they're mandatory in areas that are closed. So stairwells, you'll see emergency phones. You also have those blue phones, those blue emergency phones you see in parking lots, outside, in large campus environments. You'll see these blue phones standing. Those are analog phones that you push a button and it dials directly out to emergency services. I'd like to touch on this customer who had a large campus environment and they no longer had any copper and everything was used and there was no way to get more utilities underground in that area. So what they had a lot of was single mode fiber. So in order to, and they used all analog. They were using analog for so many different things that they needed analog services. So how did they do that? They deployed a optical LAN just specifically for analog services, and they installed ONTs that broke out large amounts of analog services on the far end, and optical LAN just for analog services. So we want to make sure to touch on that anything portion when we look at analog. What falls in line with that is intercom paging systems. A lot of these are going over to VoIP services. So we have digital audio PA systems. This is when we get into our airport technology, and we're using handsets all over airports and these large facilities to communicate across multiple levels, multiple frequencies. We're connecting these systems through optical LAN and segregating these systems. We have our entry video phones, right? Everything's being secured and locked down. We're installing video phones outside offices, outside of facilities, because we want to control who's entering the facility before they're given access. And then we also have paging systems within facilities, two-way communication, one-way communication systems, and all of that's being converted to IP, and we're deploying all of those services with optical LAN. Security devices. We've touched on this a bit, but some people don't actually understand how many security devices we're starting to see in these facilities, from IP security cameras. We all already know that, right? Door access systems, and door access systems some people say, "Oh, I just need a network drop in the IT closet." A lot of those aren't always in the IT closet. That you need a network connection at every single door. So with these deployments, we're able to install a single ONT at the door, operate the door, the security camera at the door, whatever control systems at the door we also need. From there, maybe we're close to that security gate that's running video and audio services. What we're also starting to see in some facilities are vast amounts of just sensors growing in facilities. So all the way from a vape sensor, right? Some people don't consider what's a vape sensor, but right, we want to know what people are doing in these facilities from an educational environment or maybe in the malls. What are people doing in these enclosed spaces? So from VoIP sensors that need to communicate across the network, security sensors, gunshot detection. These are growing concerns in some of these verticals that all run across our network, that all require an Ethernet connection and some hardware to go with it. So with optical LAN, we're able to consolidate all of these devices in a single area, provide a single ONT, and connect all of them from a single strand of fiber versus home run 8 pieces of copper 300 feet. As I mentioned, we were going to touch a bit on this AV and meeting room space. What's also growing a lot is this AV environment and digital signage. When we consider digital signage, we're looking at players that sit behind every TV. All of these would require a network connection in addition to probably the TV itself. So just at a single TV, you're probably going to need 3 Ethernet drops just to run, maybe an encoder or a decoder, a signage player that's back there that's probably managed from the cloud or locally in the facility itself. Plus, these smart TVs are all displays that people like to, put their Netflix on, right? We have interactive wayfinding displays. These we typically see in lobby spaces. These are touchscreen panels to provide content and information from schedules, posted information. All of these require network connections. And then we look at AV control systems. This is a space that some people think can only be done with their switch gear and their hardware, just because we're doing too much. There's too much going on our network between all of these encoders and decoders. They're talking on the network. They kill our network, right? They bog it down. And so a lot of these manufacturers and vendors say, nope, you got to buy our equipment. But with the right the right deployed system and configuration, optical LAN can actually handle all of that chatter on the network by segregating it, sending it different directions out a different port on the OLT, and really consolidating these networks to allow it to be done with optical LAN and still eliminating other layer 2 or 3 equipment at that level, depending on your control system and an AV environment. So we like to touch on that a bit because people are kind of skeptical on that AV environment. When we look at component video, this was kind of brought up in that hospitality environment on the components of the equipment itself. These ONTs, they come with analog ports, they come with RF video connections. The RF video doesn't come from the OLT, it's a third-party equipment. What it is it's actually inserted into the fiber on a different wavelength at 1550. What we're doing is we're sending different wavelengths across our single strand of fiber. We're sending downstream wavelengths, we're sending backup at different wavelengths to communicate all of these things. So with RF video, it's just another piece of hardware. We actually inject the wavelength with a wave division multiplexer into that optical fiber, and then we send that in the downstream direction, and the ONTs pull that out. So just another add-on to these systems. we like to touch on the anything. We really are hitting anything in all of these environments. Anything you're doing with your legacy networks, we are doing all of that with optical and more, as you saw with that RF video.
Excellent. Thank you, Blaine, Brian, and Chad. Great job. We do have a couple of minutes left for some quick questions, and I think one of them really hits to what you just mentioned there, Chad. The anything aspect. We have an attendee here that has asked the question, how do we provide signals to cameras and access points which are PoE powered? So there's a demand for that electricity at that endpoint. And, you know, again, what makes that value of optical LAN being able to hit anything and anywhere? Anybody want to chime in on what they think is the best way to solve that PoE solution?
Yeah, we probably all could touch on that. I can jump in a little bit though. So all of these ONTs you can purchase. They provide PoE services and now even more PoE services. We're able to provide PoE plus out of these ONTs. One thing is these ONTs do require power, right? We got to turn it on. Everything between the OLT and the ONT is passive. It is fiber. The ONTs do need power, so either we're locally powering those, you know, at the wall, or we are remotely powering these with a small form conductor copper cable. At that point, we are reducing a small limitation, but we are not held to that 300 feet. We can go much further than that 300 feet, even remotely powering these systems. We can wire a whole, you know, middle school from a single closet. We can wire a whole building from a single closet. You can install those remote systems differently. But yes, and in turn to answer the question, we are feeding and providing PoE services.
Excellent, excellent. So a lot of different ways to skin that cat. Again, getting us anywhere and anything, any type of application or product, just about any vertical out there that we've touched on today can be hit. I think that's a real testament to what you can do with the optical LAN, and you've kind of broken that barrier of limitations. We have another question here that came up. What about interoperability between different manufacturers? So that one's kind of a tough question because most manufacturers like their OLT and their ONTs to be able to communicate. They have their own management styles and stuff to make sure that they can offer all of the great features that they're trying to touch today and be able to give you that one pane of glass type operational ability. There are customers out there that have demanded more interop. So they've put out RFPs and had different vendors apply to those RFPs. So there are a few out there that will allow interop, but you're going to find that they're probably a little bit more limited on their capabilities when you do that. I think everybody on the call today addressed the issue of a variety of ONT types. So having enough flexibility and styles and types and manufacturers, you're still pretty solid on what you can do within a network and that survivability of that network. You guys want to add some color to that, clarity?
Scott, I think you pretty much surmised it. There's a standard, which is OMCI, that folks follow, but you're going to lose some of that, some of the capability once you start doing some interoperability, and there's only a few that support that right now. It's kind of like if you took you know, Aruba ClearPass and you can integrate it with anything, but if you integrate it with Aruba, it's gonna have more functions and features and bells and whistles. So that's the only thing I would add.
Excellent. Thank you, Brian. Appreciate that. All right, ladies and gentlemen, we are about out of time here. Again, I'd like to thank Brian, Blaine, and Chad for being our presenters today. Again, sharing their time, their valuable time to this. What I'd also like you to do is encourage everybody to review APOLAN's association information on the ending slides when you receive a copy of the presentation. There'll be an eval survey coming out to you. So on behalf of everyone at APOLAN, we'd like to thank you for joining us today. We look forward to seeing you again and at another APOLAN webinar or at some of our events that we support. Thank you all for joining us. Have a great afternoon.